Today we're going to start identifying conic sections from equations. So what is a conic section? A conic section is just the intersection of a cone and a plane. And I actually now have a cone in real life that you guys can touch. It's made of wood. That we can take those apart and kind of see where the heck they come from. There's going to be 4 basic conic sections. Some of these you've heard of before. Some of them maybe you haven't. One of the ones that you should have heard about before is parabolas. Parabolas you should have been talking about probably since Algebra 1, to be completely honest, and continued on in Algebra 2. Another one that you guys might have heard of is something called circles. The one that kind of looks funny, named an ellipse, is something that you have heard before, but you probably haven't dealt with before, called an ellipse. And that's just a fancy word to say it's an oval. And then the last one that we haven't talked about, but we're going to take a slight look at, is something called a hyperbola. So, what the heck is a parabola? Well, parabola is the set of all points that are the same distance away from a given point called the focus and a given line called the directrix. Did you guys know that there are 2 different ways to go? One of these parabolas you guys have talked about before. One of them you haven't. So we're going to be looking at functions and non-functions at this time. Putting the fun in function. Alright, so horizontal parabolas are going to open up horizontally, surprise, surprise, which means that it's going to either open right or left, versus vertical parabolas are going to open, well, vertically, which is either up or down. So vertical parabolas, let's start with that one because that's one that you've heard of before. Alright, so we've got a happy little parabola going on there, for example. And somewhere in there, we've got this point called the focus. All right, so it is always going to be inside of the parabola. It will be a certain distance away from an important point called the vertex, which we will talk about later in this particular chapter. But for right now, you should know what the vertex is at this point. If you don't, come and see me. All right, and likewise, the directrix is going to be a given line. It is never going to cross through the parabola. It is always going to run away from that particular parabola. It is never going to cross. It is never going to touch. Not quite parallel, though, so I guess you might not necessarily consider it skew either. Interesting. All right, but that line is just going to be called the directrix. All right, versus a horizontal parabola. Horizontal parabolas are going to be ones that look like little C's. All right, they open side to side. And again, we're going to have this little tiny thing called the focus that should go inside of the parabola. And it's going to be a certain distance away from the vertex. And then the same distance away from the vertex as the focus is going to be the directrix. And again, that's just going to be represented by a dashy line that will never touch the parabola. It is not the axis of symmetry, even though it is a similar marking as far as being marked with a dashy line. Okay, the next piece of information you might have heard of is a circle. A circle is just a set of points that are all equidistant from a given point called the center. So hopefully at this point in our lives we can draw dang near a circle. It doesn't have to be perfect. Obviously mine is not. Draw that little center there and you're done. Alright, so the X in the middle is always going to be my center. And that's about it. Alright, and I guess I should have labeled that that is called a focus. Up here. Whee! But that's a lot of arrows. Anyway, I try to keep things less cluttered. Alright, the next little particular bit that we have is called an ellipse. Again, an ellipse is just a fancy way to say I've got an oval. So basically, oval or circles are ovals, but ovals are not necessarily circles. All right, so if I want to take my circle and I want to make an ellipse instead, I'm going to have a vertical major axis, which means that my vertical bit should be longer on this particular object. All right. And an ellipse is just a set of all points that have a total fixed distance from 2 distinct points called the foci. So guess what? There's going to be these fun little foci that we'll talk about finding here later. And they're going to be located inside of that ellipse. All right. But then if I wanted to take my circle and I wanted to elongate it horizontally, it's going to look horizontal real quick and call it a day. And then my foci are still going to be inside of that. All right. So it's kind of nice. Kind of cool. All right, the last one that we're going to talk about is a hyperbola. A hyperbola is just a set of all points whose difference in the distances from two fixed points, called the foci, or foci, whatever you want to call it, is a constant. A hyperbola basically looks like two parabolas. Hyperbolas are also the only conics that have asymptotes. Yeah, those are coming back. All right, so hyperbolas on a vertical axis, which means that these parabolas are going to open vertically, which vertical is straight up and down. So I should have a parabola-looking thing going this way, but I said that there's basically two parabolas, so if I have one going up, I should also have one going down as well. All right, and then we'll talk about how to find these asymptotes, but basically, the asymptote should be following those arrows off to the side. Sorry, that was a distraction. All right, and then if I have a hyperbola that has a horizontal transverse axis, that means that I'm still going to have these asymptotes sitting here, but this time my parabolas are going to be opening up horizontally, which is side to side, which means that one of them is going to be going to the right, and one of them is going to be going to the left. All right, and we're still going to have foci involved in both. All right, what are we going to be doing with these today? Well, we're going to be doing is looking at equations and trying to identify which conic section is represented by said equation. So we're not going to be graphing them, which is why I'm not trying to emphasize them too much. I'm just basically trying to show you their shape. No, we're not. So what do these equations look like? Conic sections are actually forms of quadratic relations, which means that we're going to be having variables squared. All right, to decide which conic we're looking at, we need to pay attention to the squared variables and their coefficients. We'll be learning the forms of each of these equations. In turn, we spend each day on them on a conic. So today we're just going to be focusing on which conic is represented by the general equation. Do we need anything special before we decide what conic we're looking at? Yes. Yes, you do. You will be referring to this list a lot until you memorize which one is which. All right, so parabolas are kind of cool because they only have one of the variables squared. So you will only see an x squared or you will only see a y squared. Circles have both of their variable squares. However, both of their coefficients match, and we'll see what I mean in a little bit. Ellipses have both of their variables squared, but their coefficients are different. All right, but their signs are going to match. So they're either both going to be positive or they're both going to be negative. Hyperbolas, on the other hand, have both variables squared, but the coefficients out in front of those, probably parentheses, will be different signed. So one will be positive, one will be negative. See you in the next video.